Hi, I'm Steve Nogar with the U.S. Army Research Laboratory. Oftentimes when we're selecting an aircraft to do a specific mission, we're limited when it comes to what the aircraft can do. So a quadrotor can hover, has a high degree of agility, but it has very limited range and endurance. It can't hover for very long. On the flip side, we have a fixed-wing aircraft, and it has long range, long endurance, but obviously it sacrifices agility. We're looking to bridge that gap and create a hybrid aircraft that can both hover like a quadrotor and then transition to forward flight. One of the challenges for this type of vehicle is the transition from hover to fixed-wing flight and then back again. Traditional vehicles either rely on over-actuation, where they have extra actuators for each flight regime, or they rely on aerodynamic control surfaces, which sometimes struggle to generate the moments needed to do this transition. Now this vehicle has the ability to tilt its rotors to directly control the thrust vector of the vehicle. This gives us extra control authority during this transition. This vehicle has a controller designed specifically for hybrid aircraft. The goal is to use a cascaded approach to control the vehicle throughout transition without switching control schemes. To start, a position controller is used that assigns an acceleration for the vehicle's attitude controller to achieve. This controller, the attitude controller, uses a resolved tilt twist scheme that uses components of the rotation matrices to resolve the attitude error. This is instead of quaternions or Euler angles, which sometimes can have errors depending on when the vehicle is doing large rotations. The last step of the control scheme is to use a backstepping approach, which considers the vehicle's dynamics in closed-loop form using simplified equations to assign the actuator outputs. This is a critical step for the vehicle being able to replicate the desired force and moments assigned by the attitude controller to achieve this transition. To verify the performance of the controller, a prototype vehicle was constructed and flown in our motion capture area. The control approach was implemented on a Snapdragon flight and embedded on the vehicle. The vehicle took off, flew across the arena, transitioned to forward flight, and then back to hover, verifying that the vehicle can indeed transition to a forward flight regime and back. This benefit, it also shows that the vehicle can do it at arbitrary velocities and isn't limited to a single open loop command to do this transition. Thanks for watching, and I hope you'll come visit me at my poster.